All right, so this should now be recording. All right, welcome to Math 12, Mathematics of Lego Bricks, Lego not Legos. And so what I want to do today is just briefly introduce myself and talk about some of the things we can do in the class. I'm unfortunately going to be going to the joint math meetings with some Williams students, so I will be gone from Tuesday to Friday, but I will have email access. So as much as possible, I want to try to set what we're going to do within the next day or two by email, so I can leave things for you to be looking at and thinking about. Okay, so there's a bunch of things we can do. I've sent you some email. I've gotten responses from some of you. It would be great to get responses from more people. We can also do that now. One possibility is a speed build. In the old days, and I'll talk about this a little bit later, there used to be multiple grades you could get for winter study. You could get a high pass, a perfunctory pass, and a fail. We've stopped doing that. Does anybody know why we no longer have grades like this for winter study? What I heard is if there's 4 different grades possible, if you don't have the highest, it's counted as a non-A grade. And this was actually impacting some people's transcripts in applying for things like law school. Given that we have a speed limit of 19 in some place and how US News and World Report creates statistics, I can see something like this as being quite plausible. And we will be talking about statistics later. This is why we no longer have the high pass option. So there's now just pass, perfunctory pass, and fail. So the first year I did this, we'll talk about this a little bit later, we did a speed build of the 3,152-piece Superstar Destroyer. My daughter does not think it is possible to build, I love saying this, the giant minifigure in under 2 minutes from unopened bags. So one possibility, if you are all interested, is do you think the entire class, and you can bring in more people, you can bring in friends, do you think we can build this in under 2 minutes? 654 pieces, what are your thoughts? Well, but so again, we will talk about more. There's a lot of you, right? So are you the best people to have building this? Okay, who might be better? Well, no, this is the question. Would something like engineering or something like that, would that be helpful? Or if you do this for a couple of days, would you basically get most of the knowledge? Who might be better? Maybe, but something else. Kids, why kids? They play with Legos, but there's another reason why kids might be better. Small fingers. Absolutely. For some of the stuff, it might actually be helpful to have small fingers. I got to be very careful how I say this because this is being recorded. If we need young kids, I serve on a regional school committee. I volunteer in the schools, okay? There are a lot of kids who would be thrilled to come to Williams College and participate in a speed build. So if we wanted to do something like that, when we did the Superstar Destroyer, one person's job was as soon as the bag was opened, their job was to look for a specific piece because we needed that piece quickly. And we had so many people that we could afford to have somebody whose job was look for that piece. There's a lot of people in this room. Most of you look like you probably have friends, so there's probably more people we can look at. I'm a mathematician. That doesn't mean some of you don't, okay? Be very careful how you interpret things. So the number of people is not going to be a problem. If you have too many people, you're going to get in each other's way. And so it's an interesting question as to, do you think this can be done in 2 minutes or less? And so if so, how do we do this? So again, I think that would be a really good challenge. What we would do is we would set up multiple cameras to record this, probably do this in Presky, make this a big event, invite the campus community. Okay. The first year we failed. We had it in under 10 minutes. We were putting in the very last thing, and it was built backwards. And so they had to quickly break it down. And it was that little damn thing to just hold the wings in place. And we came in a little bit over 10 minutes. And so the goal was to do it in under 10 minutes. So we then opened up another box. And one of the groups that was building one of the giant wings of the Superstar Destroyer dropped the wing and it shattered, but not completely. And this was a great lesson. What should we do? And they decided to try to fix it on the fly. We did not practice failure nearly enough. We should have practiced failure a lot more. And they were off by 1 row, and we took over 11 minutes. The next year, we did it in under 10 minutes. The students were a little bit more motivated. I told them, everybody gets a high pass if we do it. And if we don't do it, everybody gets a fail. And you're going to have to live for the rest of your life with a I failed Lego in college on your transcript. But we practiced failing. We practiced, what do you do if things go wrong? This is what I love about this class. This is an opportunity to talk about life lessons. How many of you play a sport either for Williams now or have played in the past? Or something okay, a lot of people. So you are used to competing under pressure. Doing this in Peresky is very different than doing it in a classroom by yourself. And when we did it the first time, there was a split between the students who were on sports teams who were excited and engaged by doing this in public with the campus around them, and the students who were not used to doing things in public. And so it's not bad to try to get used to doing things with attention on you. My department is the only department on campus to still require a public talk before we let you graduate. So anyways, okay, so it seems like there's interest in doing a speed build. I would like to see that done in under 2 minutes. I think there's enough people that it has a good chance of being done that we can split this up into lots of different things. In previous years, we've built bridges to honor Martin Luther King Day. We've done speed build. I've done a lot of stuff with Rubik's Cubes. Love Rubik's Cubes. Have people seen cubes like this before? So you're used to like 6-sided cubes, right? Yeah, I'm a little bit more advanced. I do 12-sided cubes. It's actually the same as a 2x2x2 cube. It just looks different. And so we can talk a little bit about this. A lot of algebra, or a lot of mathematics is pattern recognition. And depending on how things are presented, they can look very different. And so that's one thing to look at. All right. So just some of my qualifications. When I got married, I actually had the top of our cake built out of twisty art on a Lego base. I had to destroy one of my Starfleet Enterprises for that. So you might be able to see a little bit of the interface. Okay. Can anybody recognize what ship this is? I'm sorry? Yep, Star Trek ship. So your one interesting thing to do is they have a lot of times minimal Lego challenges. Using a small number of pieces, can you make something that's identifiable? They often have advent calendars, counting down towards Christmas or whatnot, and they have small little Lego things that mostly look okay. What can you do with a small number of pieces? Something fun to try. All right. So since there seems to be interest in this, world is very different from when I was a kid. You can go online and you can download, the instruction manual. So if you lose pages or whatnot, not a big deal anymore. And so we can talk about how we would break this up, how we would try to figure out how to do it. Anybody want to guess how many bags they break this into? Four. Why 4? Okay. Anybody watch the TV show Friends? 6. Why 6? What would you break it into? What would you break it into? Okay, so legs could be 1. What else? Arms 2. Middle 3. Head 4. Hat 5. So it comes broken into 5 bags. We have to decide what are the rules for the game. Can we break them up into whatever bags we want, or do we have to do the bags that they come with? And then how quickly can we spread things out to get people to work on it? So everybody can go through and look at the different bags. One possibility is to just keep it the way they have it. In the Superstar Destroyer, there were certain parts that were much easier than others. And there were parts that had to be done quickly because we were building on them. So we had some elementary school kids building a little cover section, and they were taking about 6 minutes to do it. We had college kids who could have done it faster, but we didn't need it until 7 or 8 minutes into the build. So if you can do it in 6 minutes, that's fine. If we're going to do this in 2 minutes, we don't have that much time to spare. One thing we can do is quickly figure out how long would it take to assemble all the different parts that were built to put together. Hopefully no more than 10 seconds, maybe 15. And then that gives you a sense of just what is it going to be like. Is 2 minutes possible? 5 minutes I think would be trivial. I don't think there'll be any difficulty in building this from scratch in 5 minutes. 3 minutes shouldn't be too bad. 2 minutes might be pushing it. So it'll be fun. So what we would do is we would break up into probably 5 groups. And then those groups might have subgroups. For each group, there should be somebody who is point person to make sure things get done. And so, yes, your job will be to yell at people if they're not playing with Lego well enough, right? That you've got to get things done. You've got to figure out, how do you want to do it? What jobs do you want to do? How many of you have ever had an unlimited budget to play with? It's wonderful. Right? We don't have an unlimited budget, but we can probably get more people if needed. We've done speed builds of stadiums and whatnot. And so you can often have people come in and train them very quickly in an hour or two if we're short on people, or if somebody gets sick at the last minute. And again, this is planning for contingency. These are good life lessons. I know one year we lost a couple of people day of the build to COVID, and all of a sudden they were in quarantine, and really can't have them building in quarantine. So what do you do? How do you prepare for whatever might happen? So there's a lot of opportunities for leadership. And again, when you're applying for positions after college, I've been able to write some very interesting letters of recommendations for people who were leads on some of the constructions. Okay. So again, doing lots of advertisement and whatnot. If we're going to do this, you want to have fun. You want to make this a campus event. You want to have appealing posters and whatnot to get people excited. For the Superstar Destroyer, as I said, 3,152 pieces. We had one person who was the second in command, and when I was gone at the joint math meetings, was responsible for making sure everything was going smoothly. There were 7 bags. We had 7 bag captains, 7 assistant bag captains. Sounds like a Sesame Street song. 7 sorters who were in charge of how do you sort all those bags. There were a lot more pieces in those bags. I hope everybody can roughly divide 3,152 by 7 and get a rough sense of approximately how big that is. It's a lot of pieces per bag on average. We're not going to have anything nearly that bad here. We actually had one person whose job was publicist. How do we advertise this to the community, get the community involved? Okay. There are unfortunately not perfect videos, but there are some time-lapse videos of just one section of the Superstar Destroyer being built. Okay. Other possible activities, as I said, I serve on a regional school committee. The kids always love it when Williams students come in, so we can definitely go down and visit. I often use Lego as an opportunity to talk about various games, just build things out of Lego. In other years, we've done stop animation, brick films, and whatnot. So again, lots of different possibilities depending on what you're interested in. Let me know. It looks like somebody might have put something in the chat. Okay. All right. Okay, good. That was just saying that they can hear things. And now it's trying to find where's the damn mouse. Okay. Okay. All right. So grading, if you really work, it is possible to fail this class. I don't think anybody has ever done that. As long as you're basically showing up and playing with Lego, you should be okay. At the end, you should write a few-page reflection of what you got out of the class. No longer high passes are sadly possible. Okay. We've also done some Lego ideas or Lego idea attempts in previous years. If people are interested in something like that, let me know. One of the difficulties is it often takes a while to get all the pieces we need. I have a bunch of Lego that I have bought over the years, so I do have a bunch of things available. One year we actually built working Lego Rubik's Cubes. So this is a really large one that I built. It does turn very poorly. Somebody has made one that's essentially the correct size absolutely amazing. I've linked to that on the bottom, and you can see what it looks like. Unit analysis. So, again, this is a math course. There must be some math that must be done, right? Out of curiosity, how many people have not taken calculus? Okay. How many people have not taken linear algebra? Okay. How many people have not taken statistics? Okay. So we don't have any of these really required for the class, but I want to give you a little bit of a sense of what can you do with some math and stats. How do you find the right thing to look at? One of the things that's absolutely wonderful about machine learning and artificial intelligence is you can just tell the computers, check everything, find something interesting and get back to me. The need for that human intuition is very different now than when I was younger, because so many things can be explored. You want to try to find what is the right statistic to look at. Does anybody know what is interesting or what statistic is affiliated with this bridge? Yes. And so in the old days, fraternities could do a lot of things to their pledges. Of course, that's changed and no longer happens, but a fraternity at MIT was interested in how many times would it take us to take one of our pledges and measure the bridge in units of this pledge from one end to the other. And I love it. It's 364.1 smoot. His name was Smoots, plus or minus an year. And so they actually put down paint marks every time they picked him up and put him down. The Cambridge police did not find this amusing, and the paint marks were removed. The fraternity did not find this amusing, so they put the paint marks back. And it went back, and eventually they said, to hell with it, fine. We'll leave the markings on the bridge. It's now been immortalized, and they actually have official smoot markings on the bridge. And when there are accidents, they report not how many feet or yards or meters the accident happened at, but they report the smoot value of where the accident happened on the bridge. It's been immortalized. If you were Smoot, how would you feel about this? You're being used as a yardstick. You can kick and scream, or you can roll with the punches. Anybody know what happened to Smoot? You can't make this up. He became the chairman of the American National Standards Institute and president of the International Organization for Standardization. I can just imagine the job interview. I don't like to brag, but I am a unit of measurement. You don't know where things will lead to in life. You don't know what opportunities. One of the most important things you can do is connect, network, get to know diverse people, make sure they get to know you, and have you in mind when opportunities arise. Have a way to distinguish yourself. There's a lot of smart people out there. And there's a lot of computer programs that can do things. It's, can you interact? Can you talk with people? Can you find what's the right thing to look at and convince someone that you have found the right thing to look at? All right, so I sent this image to people. One person did respond with what this is. This is the occupancy of Airbnbs in a certain day in April in 2024. Does anybody notice anything interesting about this? Yes.
Is it the solar eclipse?
It's the solar eclipse. And you can see there's this orange region of 100% occupancy. And there's other places, around the country that are fully occupied. But there's definitely a band over here where something is happening. Sometimes it's really obvious what's going on and that there's something to look at. If you see something like this, you should be, what the hell is going on in this curve? There's a story going on here. And again, how many of you are thinking of a career in finance? So you're going to be in situations like this where you're going to have massive amounts of data and you're going to be trying to detect patterns. It's not always going to be this easy. Here's one of my favorites. This is the Super Bowl a couple of years ago between the New England Patriots and the Rams. most of the country is either rooting for the Rams or against the Patriots. Who is either rooting for the Patriots or against the Rams? Which regions of the country? And why? At least one is an obvious. New England. Okay. I'm not even going to ask why New England is rooting for the New England Patriots. Okay. Who else is either rooting for New England or against the Rams? Do you know why? Because of the pass interference that was not called. So in the NFC Conference Championship that year, there was a blatant pass interference that should have been called. And if it had been called, the Rams would have almost surely lost, and the Saints would have gone to the Super Bowl. I have a friend who is involved in newspapers and whatnot in New Orleans. And he basically told me that at the bars for the Super Bowl, they didn't broadcast the Super Bowl. They just rebroadcast one of the old Saints Super Bowls. They were just so furious with that call. Anybody else rooting for the Patriots or against the Rams? Yes. St. Louis. Why is St. Louis? Yes. What is the story?
The Rams just left St. Louis.
The Rams had left. I was very careful. I was saying New England Patriots. I was saying the Rams. I was not saying the Los Angeles Rams. They used to be the St. Louis Rams, and they left. And so again, when you have something like this, try to find out what are the places that are different, what's going on, what's the story, what's the right statistic to look at. So I'll do one last one. I'm teaching probability in the spring. This was from, I think, the first day of probability a couple of years ago. The distribution of sunrise and sunset times in North Adams in 2019. Anybody notice anything interesting about the sunrise and sunset times? Does this look like what you would expect? Yeah. Yeah, it's daylight savings. Yeah. So it's moving nice and continuously. Then all of a sudden, you've got two places where something is happening. And that's because of moving the clocks forward and back. Okay. So what do you think would be a good statistic for a Lego set? I'm trying to, and I'm keeping the question really vague. I've got Lego set 40649, the giant minifigure. I'm trying to understand, is this set worth buying? What statistics do you think I might care about?
Block per dollar.
Good, block per dollar, cost per piece, right? If the cost is very low, but the number of pieces is very low, I may not be that excited. If the cost is very high and the number of pieces is very high, okay, well, I'm getting a lot, but maybe I might be getting a better value for something else. So I think cost per piece is one of the best statistics you can look at. Anything else you might care about when you're looking at a Lego set? Cost per piece, I think, is great. There's one other natural statistic to look at. Okay, so one thing could just be maybe how long is this going to take? My brother and I have argued for years that it's actually cheaper to buy Lego sets than daycare. Especially if the kid is young and you buy. But if you think about how long it takes to build a set, and if you can keep people amused and learning and creative. So one possibility could be, how long does it take to make this set? What else might you be interested in? Nowadays, people don't break down. How many people have at least one Lego set? How many people break down their Lego sets and make new things? It happened a lot more when I was a kid because the Lego sets sucked. Yeah, you would not want to keep the ship or whatever that it came with. You would typically break it down and then just put the pieces in a giant bin and build again. So another one you might want to look at is the different types of pieces. So here, again, these numbers are a couple of years old. This was 560 pieces for an X-Wing, $120 or 21 cents per piece. Here was a Lego Friends castle, 22 cents per piece. The Superstar Destroyer, it's sadly no longer available, was somewhere between 19 and 25 cents per piece back when I was doing the first Lego class. The London Bridge, 5.6 cents per piece. That's tremendously better. Oh no, wait, we do have some people here from England, right? So is this because England sucks and nobody really wants the London Bridge? No, I'm proposing this as a possibility. Okay, we can argue. Why do you think the London Bridge is so cheap? Why do you think it's such a cheap cost per piece?
It's charitable.
It's charitable. There's so much demand that you have economy of scale, right? That everybody is going to want to have one of these so we can afford to mass produce them. I think this was advanced in jest, but in many things in economics, that is a legitimate reason why certain things become cheap, because you can afford to produce so many of them that the cost goes down. Why do you think the London Bridge might be so cheap? Conjecture.
Doesn't have like a brand name attached to it, like Star Wars.
Good. So one possibility is, if you look at the other sets I'm showing, Disney. Actually, no, this is Disney as well. These are major brands. These are major franchises. If you were Disney, would you let Lego build your stuff for free? Why not?
Because you own the ideas.
You own the ideas. And so Lego could say, well, look, if we can build Lego stuff and sell, that's going to increase demand for Disney products. And people will want to buy more other products. What would you respond if you're Disney? We can profit from this one as well. And if you're making Lego Disney stuff, you will also be able to sell more things if our stuff is more successful. So you'll profit from our advertising as well. So that there should be some kind of agreement we can come to, but we should be getting something for you to be making our sets. And so if you're Lego now, your profit margin is going to be maybe smaller on something like the X-Wing or a Disney castle, because you have to give money back to the Disney Corporation. And then you have to ask, are you making enough in additional sales so that it's worth it? So again, there's lots of things you can do. There's a lot of advertising and marketing that you can read about stuff like this and try to figure out how much is it worth to do something like this. How many of you have ever seen the movie E.T.? Right. What is the candy in E.T.? When the movie came out, everybody would have known it, but now, okay. Nobody knows what was the candy in E.T.? Reese's Pieces. Does anybody know what was the original proposed candy? M&Ms. But the makers of M&Ms didn't want to give you permission for free. And so they said, all right, fine, we'll use something else. We'll use Reese's Pieces. And sales for Reese's Pieces went through the roof because of the product placement. So sometimes, it's an interesting decision. Do I charge you for this? Or would I say, I like the product placement, not just because it places my product, but it prevents other products, other competitors from getting placement. I have watched a bunch of sitcoms over the years. When I was young, TV show cartoons were basically just 20-minute advertisements for toys. Nowadays, there are definitely a lot of drama shows where they have a lot of very good strategic product placements. If you've watched the Austin Powers movies, they have a lot of nice jokes sometimes about product placements. Mystery Men has some nice jokes about that. But it's, sometimes you're willing to do things just because you want the placement and you want to prevent your competitor from having it. So one possibility for the London Bridge being so much cheaper is that they don't have to pay money to Disney. But we're talking about a factor of 3 to 4. That's a lot. Can you think of another reason why the Tower Bridge might not be as highly priced? Yes. Yeah, I mean, if you look at the Tower Bridge, you've got a lot of very small brown box pieces. So the piece complexity is actually very low, and they may not be as desirable pieces. And so something like that is going to greatly drive down the cost. You also have more pieces here. You have over 4,000 versus 3,000 and whatnot. And you might start getting an economy of scale that the larger the set, you can afford to have a little bit lower cost per piece because of the volume that you're getting. He sadly opened it, but my brother got a Millennium Falcon when he got married. And I think it was around $500 about 15 or so years ago. Now, this is one of the most precious sets to get. Lego is actually not a bad investment. Another good investment is US Forever stamps. Your prices of stamps don't go down. All right. Talk a little bit about Lego ideas. If people are interested in trying to build something, let me know. I'm going to skip what the team did a couple of years ago, but we were plotting over here some of the Lego ideas and the price per piece. And you see roughly a linear relationship. So if you haven't taken that much mathematics, basically just take your hand, put it over the data, and it looks roughly linear in a certain regime. As you start going further and further away, you start to worry that maybe your extrapolation is not so good. I will risk doing a little physics. If you are on a train traveling 100 miles per hour and you're jogging on that train at 10 miles an hour in the same direction as the train is going, how fast does it look like you're traveling to somebody at a train station as you go by? So how fast does it look like you're going? 110. Are you going 110? No, according to special relativity, it's not quite 110. Speed is not quite additive. But for very small values, the difference is so small that we can't really notice it. You have to take into account relativity for GPS, because we need things extremely accurate. But if you just have people going by on the train, it's going to look like 110. And the problem is trying to extrapolate from a regime where you gathered your data to a regime where you have no data at all. And I still remember a quote from my physics book in high school about special relativity, where it said, these results may seem counterintuitive at first, but you have to remember most people don't have experience traveling at 3/4 the speed of light. I liked the most people. I've never met anybody who's had any experience traveling anywhere near, the speed of light. But you have to be careful when you have data. Can you trust that it will hold in different regimes? As you start to get more and more pieces, maybe you become a new type of classification. All right. And so we just plotted things a little bit over here. Here's putting in what things are. The Tower Bridge comes in very low in terms of price per piece. Interestingly, things like the Disney Castle, the Death Star, it's not too bad with the line. Oops. Okay. I'll skip that. There's a lot of different science papers. If people are interested, I can send more details. Here's a nice one: Lego in Science Biocomplexity. How many of you have done logarithms in school? This is basically just, are you awake right now? Everybody's hand should be up. I'm on a national math curriculum. I know logarithms are taught. How many of you were told why we care about logarithms? Okay, why do we care about logarithms? Okay, what's useful about logarithms? I'm sorry? Okay, but why? Why do we care? It linearizes many data. So if you have relations that are not linear, if you do a log or a log-log transform, things that don't look linear now look linear. And if you do some intro stats, one of the things you learn is how to find the best fit line. And this allows you to predict very well a lot of future things from existing data. But the relationship has to be linear. Most things in life aren't linear, but frequently they become linear under a log-log transform. The other reason why we like logarithms is they allow us to compare things across many orders of magnitude. So if you want to compare an atom, a human, the Earth, the sun, the Milky Way, there's so many orders of magnitude between them. When you compare the sun and an atom to the Milky Way, they're both essentially size 0. You really can't tell the difference. But on a log scale, you can see the difference. So one of the things we can do is we can look at piece complexity. How many pieces does a Lego set have? And how many different types of pieces does it have? And use maybe the number of distinct types of pieces as some kind of way of discussing how complex a Lego set is. You always have to be careful to make sure you have a good metric. What might be bad about looking at just how many different types of pieces do you have? What could be bad about that as a measure of complexity? Right, so if I have just one copy of one special piece, that now counts as a new piece towards my complexity. And that's just as valuable as having 10 or 20 of them. And so you have to be very careful as to what is the right statistic to look at. And it's often not clear. And if you change your definitions of things a little bit, you can definitely get different results coming out. And so over here, piece complexity as a rough rule of thumb is not bad. But you might want to refine that a little bit. Maybe I want to have different weights based on how many times the piece occurs. That I get 1 full point once it's occurred 10 times. Maybe half a point if it occurs, something like that. Okay. But it is amazing how this seems to track beautifully, on a log-log scale with the size of the sets. Which kind of makes sense. As your set gets bigger, what can you start to do when your set becomes bigger? You can have more detail. And if you want to have more detail, then you need more special pieces. So there's a lot of things that Lego has done on many different scales. You have the really small, like 20-piece Superstar Destroyer versus the 1,000-piece Superstar Destroyer. And you have a lot more detail you can add on the larger ones. My son and I are looking at right now the Lego Titanic. And I got to be careful because this is being recorded. It has some great detail on the exterior, but it doesn't have as much detail on the interior as I was hoping for. With this many pieces, I thought there would be more that you could do to have it playable. All right, I will skip this right now, but there's a lot that you can look at. Any biology or chemistry people here? All right. So a really interesting question is, counting how many ways can you do things. So the standard problem is always using 2x4 Lego bricks. And I think the original question was, if I give you 6 of them, how many different structures can you build? Nothing that you would really want to. In some sense, there's infinitely many structures you can build. Because if I put 2 pieces together at a right angle, and then I just pivot a little bit, each angle technically counts as something distinct. So you might want to start putting in restrictions. And again, for a lot of problems in life, you have to decide, what do I want to study? What do I want to count? Let's say that pieces have to either be parallel or at right angles. The next question is, if I give you 6 pieces, do the 6 pieces all have to be connected? Does it have to be 6 units high? So you have to be very careful and precise. And then I won't do this with Legos, I'll just ask. Has everybody here played tic-tac-toe, or if it's called something else in your homeland? Okay. Everybody's played tic-tac-toe. I am undefeated at Williamstown Elementary. I have never lost. If anybody feels that they can beat me, I'm happy to rumble. If people are interested, one of the things we can talk about is some basic game theory. Lego makes wonderful medium for doing stuff like this. There are things you can do to make tic-tac-toe interesting. One which my family and I have come up with recently is you play to lose. Your goal is to force the other person to get 3 in a row. There's also bidding tic-tac-toe, where each person starts off with a certain amount of money, and whoever bids the most gets the first move. And the version I like to play is you then give the money to the other person. So if you bid too much for the first few moves, you might have great board position, but then maybe the next person can get the next 3 bids and win the game. So there's a lot of variants of tic-tac-toe that are interesting. The initial version of tic-tac-toe, once you get of a moderate age, is boring. If you play it reasonably sober, it will be a draw. Okay? How many opening moves are there in tic-tac-toe? 9. Up to symmetry, how many opening moves are there in tic-tac-toe? Up to symmetry, how many distinct types of opening moves are there? 3. You can move in one of the 4 corners, one of the 4 middles, or the center. And it turns out that if you move in the center, there's only 2 responses, a corner or a middle. And if you move in either the middle or a corner, each one of those has 5. So there's really only 12 possible board states up to symmetry after 2 moves. Much better than 9 times 8 or 72. So one of the questions when you're building with Lego, what do you mean by asking how many ways can I build? So if I snap 2 pieces together, am I allowed to rotate it? Well, this is if I rotate it, do I consider that the same or not? It's now going up to the left versus up to the right. Do you consider rotated Lego constructions to be different? If so, it makes the counting a lot harder and a lot more interesting. If you're playing tic-tac-toe, does it really matter for an analysis purpose which opening corner we go to? No. But in chemistry, when you're looking at compounds, this is called chirality, when you can have the mirror image of a structure, and it can make a huge difference in terms of what it does, in terms of does it save you or does it kill you? So it can become very important to take into account, do we have something or do we have its mirror image? I'll skip this for now. So I believe the answer is a little bit under 1 billion, the number of ways you can combine 6 2x4 Lego bricks at right angles. I can't remember if this includes they don't all have to be connected, but they do have to be at right angles or parallel. And you can start by trying to find a good way to enumerate and start looking at how many ways can you do it. So how many ways can I do 1 brick? 1, right? This is not a hard question, right? With 1 brick, there's really nothing I can do. With 2 bricks, you can start thinking about all the different ways I can do it. I can have it so that they align perfectly and slide it down. It can either be leaving 3 open, leaving 2 open, leaving 1 open, leaving none open. And then as I go in the other direction, it's really the same by rotating. And I can put it on the side. But I could also put it next to or separate it. And so it starts becoming harder and harder because as I start to build, I'll use slightly different pieces, it's possible now that at a later stage, I could actually put something coming down again lower. And so one of the greatest challenges is how do I go through and count in such a way that I get everything and I don't double count anything. So if you're interested, again, no is perfectly fine, but if you're interested in some deep, hard mathematics, it is a non-trivial problem to count something like this. All right, and so I've got a link to the paper, and here is a little table of how many ways you can do it of various heights with 6 bricks. Why am I not including how many ways you can have a height 1 with 6 bricks? I'm sorry? So it comes down to, what's your definition? How could you have 6 bricks and have your whole structure have just height 1? Okay, just put them all on the table, unconnected, right? So how many ways are there to have something of height 1? There's really only one way, because they're disconnected. And then say, look, if they're disconnected, we can then just put everybody and say some configuration. And so the height 1 is not that interesting. Are you which height is the most frequent? Yeah, it's 4, it's not 6. Does that seem surprising? So there's 2 ways to do this. One way is I could have asked you in advance, which height do you think is the most likely? Which one do you think occurs the most? The other way is, here's the data. Now give me a story as to why this is reasonable. So again, whenever you see information, and again, this is supposed to be a Springboard class, try to see, does this look reasonable? Is it surprising that there's more ways to do a height of 4 than a height of 6? So why do you think 4 might be more likely than 6? Yeah, you can go up and down. So if you're going to go for 6, every time I have to put it on the piece that was just added. That's the only way I'm going to get up to height 6. Whereas if I want to get to height 4, I can go up, I could then go down, I can go up again, either from the piece I just added or the one. So there's a lot more freedom. So to me, it's not surprising that there's more ways to do it of height 4 and height 5 than of height 6. Interestingly, height 3 also beats height 6. And if you think about it, it's not that surprising in hindsight, because if I want to get to height 6, every moment in time, I have to take the brick I just added and I have to do one of my standard things. Now, if I'm allowing symmetry or not symmetry, that's going to change the counting a little bit. In the initial stage, when I'm adding one brick to the other, I have a lot of symmetry. But once I've started adding things, now it actually matters which way I put that brick on the previous one. All right. Is there anybody here who's a potential math major? Okay, so for the potential math majors, there is a beautiful website called the Online Encyclopedia of Integer Sequences, the OEIS. And if you have a sequence of numbers, you can actually plug that in and it will tell you all the places it knows where this arises. It will give you formulas and whatnot sometimes. And so if you put in the stuff for how many ways of your certain number of bricks, it turns out this has been well studied. We've built suspension bridges. This was it took 3 years to get to the final stage in this, to convince Williams to let me do this. So we first built a bridge over the mantle in Paresky. Then we eventually built one on the ground floor. And then eventually we built one, over the overhang. We actually had students in safety harnesses with the Williams Outdoor Club, making sure that everything was done safely. We had the bottom cordoned off. We did lose a few Lego minifigs as we were building the bridge, unfortunately, but all the students did survive. I have listed a bunch of mathematical topics. I've sent you the slides. So, here's a subset of things that if anybody's interested, you're happy to talk about. Just going right now, just so that it's, showing on the video. So if somebody hits pause, they can see what it's there as well, but I will post these slides in a few minutes. Okay. All right. Anybody ever play Atari? This is actually a Lego set. And so, to me, one of the things that's absolutely remarkable is how well things can be done now with Lego. This is the actual video game. This is the Lego version. Anybody ever play Nintendo? if you haven't seen it before, you should really look at the evolution of Madden football. Even if you don't like American football and you don't like video games, to just see how the special effects have changed in the past quarter century from where they started to just how realistic things are right now. This is actually not a real, this is a really good looking Lego set in terms of, I grew up with Nintendos like this where you would open up, put in the cassette and whatnot. The TV screen over here, it actually scrolls. And so you can actually have the Lego Mario jumping up and down. If people want to try to build something, anybody ever play Mancala? So it's a nice game. My kids and I built a really, I don't want to say anything too bad because it's my kids. We built a workable Mancala set years ago. Right? And so, wasn't that hard to do. One possibility if we're looking for something to build as a Lego idea, building a good Mancala set, I think is something that would be reasonable. We've tried last year, didn't get too far about building a Lego backgammon set or combined backgammon chess checker set. And so there are already chess checker sets on the market. Backgammon isn't that much harder to add that as well. I forgot to bring this, I have this in my office. This was a birthday card I made for my daughter out of Lego years ago. One of the difficulties is just how thick things are. On the inside, you can actually take out the pieces and play tic-tac-toe on it. And so just, try to be creative if you want, try to think of things if you want to do a Lego idea that we can do. The difficulty is always going to be the scale at which you do things and how long it takes to get the pieces. One of the nice things is I have taught this class every year, even though I only have to teach every other year, except for would have been January 2021 when there was no winter study because of the pandemic response. So I have a good amount of Lego pieces on reserve. So we do have a lot of things to play with if you are interested in trying to do something like this. All right, so I think this is a good place to stop. I will stay around for a couple of minutes. I'm not going to go into that in case anybody has any questions. And then what I will do is leave. Let me just stop recording first.